This conference will now be recorded.
Hello friends, welcome back to the demo session on data science and applications of data science. So we'll start the session. Just give me a minute for setting things up. So there are two modes of communication I would recommend. First one is using the chat platform. There is a chat window out there. So if you have any questions, quick ones, you can just put it in the chat window. I'll be monitoring the chat window, and if I see any questions, I'll be answering them while while I continue the session. If you have a lengthy question which you would like to interrupt and ask, then please take your judgment and try to interrupt the session and ask it. If you really think you can wait for some time, then we will be giving some pause at equal intervals. I would ask if you have any questions, then probably you could then post your question at that time. For chat, you could just put the question whenever you have. So whenever possible, I'll be able to answer them. All right, so these are some of the basic etiquettes I would like to request everybody to follow so that the session will be pretty smooth. I do see a good number of people joining. There will be few more people joining as and when they join the session, they'll be able to get the understanding. So let us start. So my name is Sitaram, and I have around close to 15 years of experience in IT. and out of which around 8 years I'm working in the data area, specifically in big data, data science, and so on. I worked as a big data architect in the past for many years, and currently working as a data scientist in one of the bigger MNC. As a part-time gig, I also do a lot of trainings. I teaching is my passion, so I like to teach things in the data science, big data, cloud computing, and DevOps and related areas, but primarily focusing on data science because that is my current forte. I'm working on that, so it would be easy for me to explain things whatever we do in the real world. Um, and I also have hobbies in sense like I would like to train some models, uh, go for conferences, uh, go for workshops um, within India and outside India, and also give some conference talks. So that is also one of my likings. That is quickly about me. I would really like to know about you people, but there are so many of them, so we would be quickly wasting time. I hope everybody is well enough. We would see a different gamut of people joining, people with having good amount of experience. They're already working in IT. They might be having 5, 10, 15, 20 years of experience also. And we might be seeing some people who are just completing their masters or probably completing their engineering and joining the company, or probably with a couple of years of experience, like 2, 3 years of experience. So what I will try to do is I'll try to ensure that we will try to make as plain as possible, so that everybody can understand all these topics in a plain, simple manner. If you have some another questions, do let me know. We will discuss them. So let me start. So today's topic, I'll be talking about more about the data science part of it. What are the different components of it? So today's session is trying to make everybody on the same page. Many of you might have gone through these topics elsewhere. Probably you might have gone through other trainings or maybe YouTube videos or some other material. But I will try to give my perspective about how data science has evolved, what are the different applications of data science, and then how we use them in our real world. And we will have another session tomorrow, which is also important, where we will talk about the end-to-end life cycle of data science, where we will take it from the base applications of data science and how we implement them in the real world. So here in this screen, we are seeing that the data analysis have been there for many years, and a lot of people, uh, famous academicians, have worked day and day night for creating applications specific to data analysis, uh, taking the data, analyzing data, and providing business intelligence systems on the data, creating machine learning systems, and how to use the data for a greater good. So a lot of work is already happening in the data science. So this is not very new now, because it has been there for many years in the past. So it is not really new. There are a lot of efforts which are spent in the AI also. So there are a lot of efforts in this in the sense like AI was started somewhere around 1950s. As you're seeing, this is the area where uh, it has initially started somewhere around, say, I would say like 1957 or so, that timeline. And after that, people have that went into a AI winter. AI winter is something like people thought that it would be a great boom. It will go like this, but it never happened that. And AI winter came. And this was the time when people invented something called as perceptron models. Perceptron models were the very strong models for neural network and deep learning areas right now. That was a time when people thought that this is going to change the world. It will make autonomous systems. People can use computers to do their work. So a lot of hype was there in those areas, and that was the time when AI was really coined. That was the time when the AI, artificial intelligence, was given a name. But it went into AI winter in the initial days because there was lack of data. So we have lack of data. Because we don't have data, it went into this first AI winter. And then later there were good amount of algorithms created in the second wave. So there is a popular algorithm called as backpropagation. So backpropagation is a very popular algorithm again in the area of deep learning and neural network and artificial neural network, where it is a very popular algorithm invented back in 1970s 77 time frame. And again it actually boomed and people created a second wave of AI. And but again it fell down somewhere in 19 ends of 1989 90. This The reason of this fall is because of less compute. So people have the problem of the compute here, because uh, we were not having enough amount of compute space. And there were also popular algorithms like CNNs, which would work on images, and all those things were also invented in this space. But because we were not having enough amount of compute in sense, we do not have CPU, we did not have disk spaces, we do not have the right amount of graphic processing units. So all those things coming together, it again went into another AI vector. And now we are in this space where, 2017, if you remember, 2017 is the space when TensorFlow was invented, which is a popular framework for Google deep learning and all. And people again started to get into this hype cycle, and many believe that this is going to may sustain, or it might excitement might fade, or it would be another bubble, right? It could be another bubble. It can burst again, but we don't know what is going to happen. But according to the evidence, if you are looking at some data, what we can think is that, because we have three important components here. First one is we have good amount of data, right? We have good amount of data thanks to big data. You might have heard like big data, where huge amount of data is being collected from varied sources. So much of amount of data is being collected, and all the data is collected. So that is the first part. And second one is you have a good amount of good compute. And again, thanks to cloud computing, and we can also say like good hardwares, for example GPUs and other things. All those things, it has gained a advantage. And the third important thing is the algorithms. So algorithms, like if you see, there are a lot of algorithms, frameworks which are released freely. For example, Google released its TensorFlow. We have Facebook's PyTorch. Likewise, we have good other algorithms like scikit-learn. We have namely pandas, NumPy, and so on. So there are a lot of famous algorithms which are now aiding for the this entire analysis, right? So we are trying to do a lot of analysis based on all these analysis. We are saying that, okay, this is going to help us in a big terms. And because of the combination of good data, good compute, and good algorithms, like good amount of data means huge volumes of data is coming. Good compute instance, now we have cloud computing, we can rent out machines, we don't have to buy them. We have availability of GPUs, CPUs, even higher memory configurations, all those things are available. And the third is the good set of algorithms, all of them coming into a deadly combination, which is giving this one a scope, right? So people are thinking that it might give a very good scope for going up. This is the direction people are betting on, and that is the reason if you see a lot of corporates are also working on creating systems which can make use of data, which can make use of the newer algorithms, data pre-processing and other things, and making use of them. Clear? So that is what we are trying to see it here. Now, next thing, if you look at it, data is everywhere, and this you might have already heard that you're consuming so much amount of data in the past few years, and data is growing exponentially. Now, this is the first and foremost component of data analysis. When we are focusing on capturing the data, huge amounts of data will be captured, and that huge amounts of data can aid for doing a lot of data analysis, right? And every year as this is growing, now here we are at 2018, but this is growing beyond 2020 and so on. So the data is exponentially growing. It is growing in this fashion, and every year there is a huge exabytes and zettabytes of data is getting added every year, and that is aiding for our analysis. Now, if you take, we will take a lot of examples of what these data can be, but all these data is kind of aiding on your analysis. Now, if I coming about data, what is the type of data? So the first and foremost data which will be uh, used is called as a transactional data, right? A transactional data is the data in which your brick and mortar companies, for example, your companies which are maybe retail, right? You can have banking, you can have uh, finance or insurance. So you name it. These are some of the names I'm giving, but no, for example, if you take an example of a retail shop might be doing regular transactions. People are coming to the shop, they are buying something. So when the buying happens, the transaction goes, and you create applications which can store the data. For example, 1 kg sugar is bought by the person, and that goes into the database. So this kind of applications, basic applications are created. So all the brick and mortar companies or regular business companies, their primary data sources would be like whatever is the transaction which is happening in the day-to-day life, right? So depending upon their business lines, so whether it could be a retail, banking, it could be travel industry, media company, it could be any other company. So based on all those things, they will be doing regular businesses, and that data will be stored. So primarily these kind of data sources will be stored in RDBMS. So RDBMSs will be relational databases. They are also called as operational data stores. Operational data stores. So they will be storing huge amounts of data into this operational data stores, or also called as ODS. And once they do the data storages, people have worked day in day out to create analytical solutions on this. So the popular analytical solutions, what you might have already heard of is you might have heard of data warehousing, You might have heard of SQL processing, right? So such kind of systems are developed, and where we are doing a lot of these basic analytical solutions, data warehousing, SQL processing, and so on, for getting understanding of the data. So you might need to do a data analysis like how many kgs of sugar sold in the month of, say, October. Okay, I need to know like how many kgs of sugar sold in the month of October, and once I know that information, then I'll be able to do some planning, maybe plan for November or December, or maybe plan for increasing or reducing the supply demand and all that stuff. So based on those things, businesses will do a lot of such kind of things. This is a first and foremost kind of data. Next set of data is called as audio and experimental data. Now this is audio data is pretty interesting because nowadays it has come up with a very intuitive applications. You might have learned about say Alexa or whatever. So you might have heard about Alexa, your Siri, your any gaming consoles, right? So all these applications which are being 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 operated using your voice, that follows this audio data processing. Now what does audio data involve? So audio is not type of a data which is can be stored in normal regular databases, so you would require file systems for this, or you would require cloud-based storages, right? So you can't directly, put this kind of a data onto any RDBMS databases. Certainly you could do, but you want to retrieve them and do all the processing, it gets difficult. And understanding audio data, because this is a binary format, audio data is in a binary format. So a format which does not give a structured information. So you don't have a structured information, so binary data cannot be analyzed directly. So you need to understand the for example, if Sitaram, you need to understand who is speaking, and once I identify that okay, who is speaking, and then based on that I try to take the voice, understand what the voice is about. For example, I say, hey Alexa, play happy birthday song. Then if I say play happy birthday song, first it needs to understand that Sitaram is speaking, and then secondly it also needs to understand that it has to go and play the happy birthday song. It would do the transcription of my voice and then create a query, and then probably hit a backend search console, maybe Google or Bing, and get your happy birthday song and then play it. So you're seeing a lot of connecting dots are there, but the primary piece here is the voice itself. Now, how to understand, how to create applications which can understand voice, the modulation of voice, understanding the intent in the voice, identifying the utterances, all these things is a bigger question. So there are a lot of applications which are being built. I just gave applications like Alexa, Siri, the gaming consoles, and so on. But you can see the speech conversation systems, like you speak in one language. Now you can create a system. Imagine I want to create a system for somebody speaking in Hindi or Telugu or Tamil or any other language, and I speak in English, and the language will be converted into Tamil or Telugu and so on. Or if they speak in that language, I will be able to convert it back to English. So such kind of applications are going to create a huge boom in the travel industry, right? So people traveling abroad, going to other countries who are very specific native languages. In such cases, it becomes very difficult. For example, if I go to say Kerala or Tamil Nadu or maybe northeastern states where I really do not know the Mizoram language or something, it becomes very, very easy for using such kind of applications which can do the conversion. A lot of work is happening in this space. A lot of experiments are happening, but we will be understanding which kind of applications could be used in this particular kind of examples. But sky is the limit for doing these experiments. Another set of data which I'm talking about is the experimental data. Now, what is experimental data? Now, a lot of experiments can be created. For example, I can take the example of COVID. Now, when I taking the example of COVID, you want to get out the vaccine for COVID, right? And that is a bigger task. Like everybody, right from US till Russia till India, everybody is trying to get out a vaccine for this and getting in a large scale and proving that it is correct and so on. So if you want to get that kind of thing, then what are the tests to be done? So you might have to do multiple rounds of tests. Imagine you're testing it on 1,000 patients. So you test it on 1,000 patients. You need to ensure that you take a right sample from these 1,000 patients. Like imagine you take a sample of 100 patients, and you can't test it on all the 1,000 patients. So what you do, you take a sampling of the 1,000 patients as 100 patients, and then what you do is you test this particular drug on that particular 1,000 patients. So if 100 patients are providing positive results, so if they're providing positive results, then you can extrapolate saying that, because these guys are having a positive result of this vaccine, then you can be extrapolated the same results to the 1,000 and maybe to the entire population. So such kind of things basically come into something called as inferential statistics. So inferential statistics is a very, very broad science in which you use data and we try to create samples, and you do something called as hypothesis testing, and so on. So such kind of things would be working where you're trying to apply the inferential statistics, try to take sampling of your data, conduct experiments. If the experiments are providing positive results, then those experiments can be extrapolated to your larger audience, probably to the group of initial patients or probably to the entire population, right? And that kind of gives a very, very positive environment in which we are trying to experiment on the data and provide a lot of results. Now, this is on the healthcare side. What all things can be done? For example, you could do oceanic research, oceanic, I messed up the spelling, but oceanic research. You could do space research, right? You could do research on earthquakes, and similar kind of things. A lot of work is happening in this space because this data is huge, right? If you take data from a Hubble telescope, if you know Hubble telescope is the largest telescope, it gives petabytes of data, right? So if you're taking data from such kind of a telescope and it gives a huge amount of data, it is literally literally impossible for doing any kind of analysis, right? So we are trying to analyze that, like how we can use use this experiments and other things which can provide better results and provide a better analysis. Now this is about audio and experimental data. Next set of data is your video and image data. Now this is also a very cool applications. A lot of applications are created in the space of video and image analysis. For example, if I take start with an image analysis, you could see like you can create applications within diabetic retinopathy. So diabetic retinopathy, I can write it here, diabetic. So diabetic retinopathy is one of the example. If you have heard about Google I/O, Google I/O maybe like 2018 or 17, right? So if you watch Google I/O's 2017-18 speech, Sundar Pichai has told that their company Google is trying to invest heavily on the diabetic retinopathy, which can look at the images of the retinal scans of the patients and can identify whether the person is having diabetic retinopathy or not. Now, this is a peculiar kind of a disease. When your sugar levels go up, slowly your eyesight would be, you would be losing your eyesight. And many people in the rural areas doesn't know that this is happening because of their sugar levels, because their body will be absolutely fine. They will think that, okay, I got some I got some levels of lost in eyesight or something, and because of that, they're losing the eyesight because of age or something. But the reason is that they might be having diabetes, and then they never realize that. And such kind of tests are done. So Google has collaborated with two of the institutes like Arvind Eye Hospitals and Shankar Netralaya. So these are the two hospitals which Google has collaborated with, and they're doing a lot of experiments on patients whom they can get the retinal scans, and with the retinal scans they will identify these spots. Like you see, like there will be spots created in the eyes. If you have an eye, there will be spots created, and those spots would like cotton swab kind of a spots, which could be identified as a diabetic retinopathy in the retinal scans. So we identify those things, and based on those, we say that okay, this particular patient is having diabetic retinopathy. The same is the case where it is applied in a lot of systems. A lot of systems could be used. Especially, this is a very powerful in healthcare, um, where you can do a lot of experiments in the healthcare. May that be cancer prevention, may that be identification of diabetic cases, your bone scans, your scans related to the DNA, or any of the any of the chemical components of bloods and so on. A lot of experiments are being done with this with the help of images. We could do a lot of work, and such applications are being built. Coming to the video data, video is where we are trying to see that uh, there are a lot of, again, a video is an extension of what image is doing. So if you take a video is nothing but you have multiple frames which are tied together as a one single video. So video basically is like stacking up all the images and you know tracking it together. But there are a lot of applications specifically in the space of video, where we are trying to look at the video and identifying, for example, identifying criminals or something like that, identifying faulty things. For example, IIT Hyderabad. So IIT Hyderabad is doing an experiment to identify a combination of municipal department of Hyderabad. They are trying to identify systems which can create, which can identify people who do not wear helmets, helmet detection. From what? Helmet detection from your CCTV footage cameras of traffic signals. So traffic signals will have these hidden cameras, or not hidden cameras, sorry. Traffic signal will have the CCTV cameras, and from the footage of the CCTV cameras they are trying to identify people whether they are wearing helmet or not. And if at all they are not wearing helmet, you're trying to capture the number plate and then trying to issue a challan then and there. So the system will do that. Nowadays you might see that people especially in India, I'm talking about. I'm not sure where you are joining from, but in India, you see that the police guys will stand and then take pictures, and those photographs would be sent out to a central station. People will look at the pictures, identify the number of the traffic vehicle number, and then issue a challan. So all this process is being automated, and where we try to identify whether the person is wearing helmet or not, and then you will try to put a fine. Same is things applied for if you are breaking some signals or taking a wrong turn. A lot of things can be used by capturing the video data. Other kinds of data types are, you can take like charts, graphs, and stats, where you will be able to project the data. There are again multiple variants of these analysis which could be done. All these things comes under something called as descriptive analysis. A descriptive analysis, where we are trying to provide a description about our data. You are providing some kind of charts, you're providing some kind of pie charts, some graphs, and some analysis. So all these things, are visual representations, and picture speaks more than 1,000 words. And it is very, very true, because if you are able to represent the analysis in terms of pictures, you will be able to see the data, and you will be able to make quicker decisions with those representations, in the terms of pictures or video, charts and graphs, and um, you know uh, correlations and so on. So all those things will help us predicting a lot of analysis, right? So far so good. You can use the chat window. If you have any questions, please post that. I'll check that and then give a reply. So next coming, we will talk about important concepts. So you might have heard about artificial intelligence, machine learning, and deep learning. These are some of the areas which basically provide a lot of buzz these days. Now we are seeing that there is a lot of analysis happening. We are trying to create applications in the science of artificial intelligence, machine learning, and deep learning. But what are these actual areas? What are these talking about is something very important. So artificial intelligence is nothing but it's basically techniques which enable the computers to mimic what humans can able to do. Okay, so it is trying to create a system in which we are trying to mimic computers, where it will enable computers to mimic what humans can do, right? And what artificial intelligence has is, it will have set of logics, it will have set of rules, rule-based engines. So it is more like a if and else conditional based engines, and those rules have to be identified by humans as well, right? So these rules, whatever are there, those also have to be identified by humans, and we need to provide those rules and make decision trees. So we are trying to construct some trees which will be helping us to create systems which will be able to identify the data and provide results. So if I try to draw a general representation of what a artificial intelligence system would look like, so it will be like a black box. Now I can call it as an AI, and then it will get some data and apply some rules, and then give some output, right? So it's a simple black box or a conditional kind of a scenario. So you can create an AI with an if else loop also. So I can write a program, if so and so do this, if so and so do that. Those rules will be provided by humans. We are providing those rules and then creating a system which is an automated system which is mimicking what humans are doing. Imagine I take a robot and I train the robot to basically give the robot with a set of rules. saying that a robot has to take a plain sheet of cardboard and it has to fold the cardboard in such a way that it will finally create a carton box, right? So it has a piece of cardboard, then it will fold left, fold right, then after that rotate the cardboard and fold it the other side. So it will kind of create grooves and then fit the cardboard into the grooves. So finally you're trying to create a box which is basically an automated way in which instead of a human working on that, you are asking the computer or the machine to work on that. In fact, machine assisted by robotic arms and so on. So you would see a lot of companies have done a lot of automations. People talk about these automations where a series of set of tasks which humans are doing, you're trying to automate that process. We know the rules. We know the rules saying that, okay, these are the set of things which need to be done. If this is happening, do this. If this is happening, do that, right? So such kind of things can be automated. And the initial usage which uh, which uh, which actually made the computers to do the work of humans is called as artificial intelligence. Simply think, if at all you are a postman and you want to sort out these post letters based on the zip code. Okay, so there are different areas. Imagine, say, Hyderabad, Bangalore, Mumbai, Delhi. If you're taking US, you might take like New York, some city in New Jersey, Chicago or Miami or any other cities, right? So you're trying to shuffle these based on the zip codes and then basic keep it into different buckets. Now that is a task of a postman. Now instead of that, if you are taking a computer to do that same task where it can automatically identify the zip codes, and based on the zip codes it has a set of rules, like if the zip code is so and so, you put it in the bucket 1. If the zip code is so and so, put it in the bucket 5, and so on. So those set of rules which create a machine, where providing a machine with set of rules and logic, and based on which it can do the decisions, is primarily termed to be as an artificial intelligence. So if you look at it, it is more like an umbrella where you can use it for creating a lot of systems. Now within the artificial intelligence, you have something called as machine learning. Now what is machine learning? Now we said that we want to give these rules, right? But if the data is difficult and I don't know the rules, for example, data is some healthcare data is about some aviation industry, I do not know the rules. Now, if I do not know the rules, how would I give the rules to the machine so that the machine can perform? So AI has evolved a little bit and tried to start applying something called as statistical techniques. So in the statistical techniques, what we do is we try to enable the machines and try to understand the relation between the data. Okay, so you give statistical techniques where you give, if I'm taking machine learning, it is like a black box in which you give input and also you give output. All right, so you give input and output and the machine will try to understand the program. You can call it as relation. What it is trying to understand, it is trying to understand the relation between input and output. How are they related? We do not know, because I'm giving some aeronautical machine related data which I have no clue about. Maybe some healthcare, some very specific brain scan which we don't have any information, some DNA sample. So we do not know that. Maybe we might know that, okay, this particular brain sample is having some tumorous cells, that we know. Maybe doctor has told, but where are those cells? How are they represented? Now, what is the relation between input and output? We do not know. So when I feed the data, input and output, to a machine learning model, this model we will be learning, we will be learning a lot of models are there. A lot of set of models are there which will help us learn all these techniques. But what they will do is they will try to understand the relation between input and output and then try to create the relation. You try to create the relation. Generally, you can call it as a program. Technically, we will call the name as model. It is called as a model, machine learning model, which is basically understanding the relation between input and output by applying some statistical techniques by which the machines can understand what is the relation between the data. Now this is good, but sometimes these input data and output data will be even more complicated. It could be some images, it could be speech samples, it could be some videos or texts or something else. In those cases, the basic machine learning models does not work well, and that's the case you would apply something called as a deep learning. A deep learning is a subset of machine learning. Now, if you're seeing, artificial intelligence is a basic umbrella. Within artificial intelligence, we have machine learning. Within machine learning, we have deep learning. Now, deep learning is further set of algorithms. These are called as neural networks. It's called as neural networks. Neural networks basically, which will perform these analysis and will help us to find out a lot of such kind of results, right? Neural networks are subset of machine learning, which will be working on speech based samples. It will be working on images, image recognition. It could be on video analysis. It could be on text data, right? So it could be on text, videos, and so on. There are a lot of applications which the input data is very complicated, right? If you take a video information, it's all binary data. You will not be able to identify the features of that. It becomes pretty complicated for doing analysis. In such cases, the neural networks are very, very good in finding relations between data. And neural networks are nothing but they are subset. They are one algorithm of machine learning. When I told that we will apply algorithms, different algorithms, so one such algorithm of machine learning is neural networks, and we can apply the neural networks for doing this analysis. Okay, so far so good. Are we guys able to follow? I just want to check if the pace is okay. Are you able to follow me? Is it slow? Is it fast? Very fast? Or at the right pace? You can use the chat window and put it. All right. Thank you very much. So there is a question that does all these involve a huge set of data? Exactly. So it will involve huge amount of data. So where we are seeing that um, where we are seeing we are trying to apply deep learning based models, then you need to have a good set of videos or good set of audios, text files. So based on that, we can analyze it. Now, there is a lot of research currently going on, which is like trying to reduce the amount of data which is required. So, for example, with less amount of data, we are trying to replicate that information and create much more complicated systems. But that still is in the works. There's still analysis happening. A lot of researchers are working on that, because if you work on real world problems, right? Especially like some startups working on it, they might not have a lot of data. So having a data certainly is a plus, but if you're not having data, you should not be into the disadvantage mode, right? So that's the reason a lot of work is happening to create systems without the amount of data, still able to apply these algorithms and get good results. Such works are still in progress. All right. Now this is clear. Artificial intelligence, I am saying that, okay, these are set of rules where we are applying, that is working fine. Now coming to the machine learning, we can say that it is a subset of artificial intelligence where we are applying some statistical techniques, so that if I do not know the right set of rules, if I do not have the SME knowledge or the information, then I can depend upon statistical models, and those statistical models will be used for the data. Now, if you go further, if my data is not strictly structural in nature, if I don't have proper input output features, then I might feed the model to something called as neural networks, which is a deep learning area where specific data types like speech, image, and other kind of things would work.
So, one question here. So,
Mhm.
do you mean that the machine learning or deep learning algorithms that we apply, they are like probably kind of a prediction or a guess than an exact answer that we look for?
Yeah, so there are a lot of related things. Mostly machine learning, deep learning, we are trying to find out what is going to happen in the future. General data analysis, whatever we do, they're descriptive analysis and predictive analytics. Descriptive analytics already talk about whatever already happened. Those are pure numbers. I'm trying to find out the maximum sale of number of cars in the month of April. Maruti wants to know how many cars were sold in April, which is zero. But how is the trend moving, whether it is increasing or decreasing? That is what we get it from the past data. It's called as descriptive analytics. Mostly the artificial intelligence, machine learning, what they do is they try to do predictive analytics. For example, if I already folded in some way and it has completed some kind of a fold, what next fold has to be done? It is again a prediction. So based on the current state, it will predict the future state. So based on the future state, we will do another fold. The robot will do a complete fold of a carton box. Similarly, looking at an image of a broken bone, I need to the machine learning model has to identify whether that is a broken bone, it needs a surgery, or it can fix it by doing some bandage and so on. So such kind of decisions can be done by these models, provided we give a lot of data. Primarily, prediction will be the case. Futuristic things, predicting what is happening in the future, is something we will be doing it. Got it?
You mentioned the retinal myopathy. So, what kind of learning does it use? The machine learning or the deep learning?
It uses deep learning. So areas which involve images, speech, and other things, it will use deep learning models. Machine learning models are very well suited if you are using more structured information. For example, data coming from tables or flat files or input-output relations, which has a clear separation of input variables. In those cases, we will apply basic machine learning models. Again, there are plethora of models there, but the clear demarcation is that if at all your data is very complicated, you will not be able to arrange in a structured fashion, unstructured data, then we are going for deep learning models. And the basic structured data, we can go for machine learning models. Does it answer the question?
Yes, very well. Thank you.
Great. So one more question people generally will have is, okay, this is all good, artificial intelligence, machine learning, deep learning, but what is data science? Where is it falling, right? And if there is a famous place in Hyderabad called as Amirpet. I'm from Hyderabad. So if you go there, the next day there is a technology released, you will get a banner out there saying that 10 years experience in so and so XYZ technology, right? And people will try to create multiple courses. There will be a course on data science, there will be a course on deep learning, machine learning, artificial intelligence, and they're both saying that they are different fields, and uh, the course there are different courses for these pieces, and which again confuse people that whether they are same or different. What I would say is all these are same, and data science is the connecting piece for all these things. For example, this is more technical. Artificial intelligence, machine learning, deep learning, these are all algorithmic process using statistical technique, rule engines, all these things. but somebody needs to feed the data into it, right? Somebody needs to feed the data into the system. Now, who will be that? Somebody need to feed the data. Somebody need to process the data. Somebody need to visualize. Now, somebody needs to visualize the data. So there are a lot of things which are involved beyond the scope of applying a modeling. So this entire artificial intelligence, machine learning, deep learning, we call that as modeling. So modeling is where we are trying to look at the data and making some structure of that or meaning of that. That is modeling. But before the modeling, you might have a lot of things like how the data will be ingested, whether it is real time or is it in a batch, right? And what are the systems which are connecting to do the data ingestion? Where the data is stored? Are we creating a data lake where all the data is stored, dumped, and then from the data lake we are applying these models? Are we doing any processing? Are we doing some joins, uh, doing some missing value imputations, changing some data, applying some standardization, scaling, other techniques? Are we doing some of those things which comes under pre-processing? Are we deploying the models? How do we deploy the models? Like, I created the model, but how do we deploy these models? Are we integrating with cloud? Are we pushing these models onto cloud? And what programming has to be done, right? So how do we visualize the data? Are there some tools which connect for visualizing the data? So all these things are external to this modeling step. So these external systems, the dots which get connected right from the data ingestion till the data visualization, data modeling, data visualization, deployment, all these things comes under something called as data science. So data science is basically like connecting dot, I would say. It's connecting all these things where you can ingest the data, we can do the data processing, we can apply deploying of the models, we can do the visualization of the data prior to doing the data analysis and after data analysis is done. So all those things will be connected, where the artificial intelligence, machine learning, and deep learning is one piece of it. It is one small piece which is called as modeling, but beyond the modeling you have a lot of other connected dots. So if you're talking to somebody who's saying that, okay, this is data science course and deep learning course, machine learning course, artificial intelligence course, all are separate, they are actually fooling you. They are not separate, they are same, they're all connected. And some people will say only learn one part, or some people say, okay, we will do only machine learning, or we will only do data science, right? So in those cases also you're missing the big picture. What I would say is we will need to have three major important things. First one is the knowledge on data science. If you're seriously thinking of it, knowledge of data science is first thing, where you will involve all these tool techniques, pre-processing, exploration, all that stuff. Second one is you need to understand how does that integrate with cloud. The knowledge of cloud computing is very, very important, because nowadays everything is being deployed onto cloud. Now when I say cloud, I'm saying like the services like AWS, Azure, Google Cloud, and so on. Now how does these applications get deployed on those clouds is very important. And the third one is understanding of deployment strategies or processes. For example, we call them as DevOps. So how does these all link together, and how does the pre-processing happens? Because this is not like a one-time activity that I create a model, get it trained, and then done. That is not happening. You need to create a system which every day data will be ingested, data will be pre-processed, data will be arranged in a proper fashion which the model can understand. And then once the data is arranged, you need to trigger another modeling program which will feed the data, create a prediction model. That model has to be deployed onto another front-end system which will be doing predictions and all that stuff. So there are a lot of connecting pieces. So DevOps is a component which will involve all those connecting pieces, right? So you might be learning about something like Dockerization, containers. You can think about Jenkins, or even more infrastructural DevOps components are there. How do we deploy? How do we, connect? How do you store, for example, Git and Artifactory, or how do we do source code analyzing? So this is not one single piece. There are a lot of connecting dots. So these are three important things which I would say, which one should get an understanding on. Primarily, the depth should be in the data science, and cloud and DevOps, I will say that we need to have the breadth. I messed up the spelling. Breadth. This is BR. Okay, we need to have a depth in data science, so we know all the algorithms, all the pre-processing things and all. And the depth should be in the breadth should be in the cloud and DevOps. Like, how do we connect those things, and how do we interact with those things is what you need to understand. Got it? Any questions? We will spend few minutes for some questions, and then we will take a small break. A quick 5-minute break, or 5 to 10-minute break. So you can post the questions in the chat window, or we can speak. So far, so good? No questions? All right. So what we'll do, we'll take a quick break. And once we come back, I'll be talking about some of the applications of data science from a real world perspective. What are the things which are involved in the applications? So we'll spend an hour after the break to understand all those things, and then we will conclude for today. All right, we'll take a quick, what's the time now? Okay, 45. So let us come back after 10 minutes. All right, so we'll come back after 10 minutes, and then we'll look at another things. So I'll talk about different applications of data science, specifically talking on social media analytics and predictive analytics. So we have different applications, real world applications. I'll be talking about those things. Till then, have a quick break and then come back. I'll come back in 10 minutes. By the way, if you have any questions, you can put in the chat window. I'll look at them and answer once I come back. All right. All right, friends, welcome back. So we'll start the session, or let's continue the session. So before the break, we were understanding about difference between artificial intelligence, machine learning, deep learning, and also the relation between these modeling things with respect to data science. Now we'll understand about different application areas which has contributed towards this rise in the data science and the applications of data science. I would say the first and foremost one will be social media analytics. Now social media analytics, what I say is the data which is collected from these large corporates, the Google, Facebook, YouTube, Instagram, Twitter, LinkedIn, you name it. All these bigger social media companies have actually revolutionized the way in which data is collected, data is saved, and it is processed. A lot of applications, a lot of tools are developed by these companies. In fact, if you see a lot of data analytic related things, we will use the tools from these companies. Many of them are also open source. Because they are open source, we could use a lot of these open source related technologies, and we can use it for the it, because they are open source. Now I can use it in any of the applications. I can use it in a lot of systems. Once these prime companies have released their open source tools and technologies, the next set of applications which has utilized data science are the predictive analytics applications. Now, predictive analytics is a science and which involves in predicting something which is happening in the future, which is not yet already happened, but which is going to happen in the future. We are trying to predict that. Now, like as this parrot or like a tarot reader or anything, we were trying to foresee what things are going to happen in the future. And that foreseeing is purely dependent on the current data, current and the past data. We're trying to follow a trend. We're trying to analyze the trend, and with the trend, we are forecasting something which goes in the future. There are a lot of predictive analytics applications which are available from past few years, many years ago also. We had this predictive analytics application in terms of forecasting, demand analysis, and so on, but primarily they were limited to single machines. Now, with the advancements of big data, cloud computing, and artificial intelligence, and so on, those systems now are capable of running from larger data centers, larger data lakes, which will give them an ability to analyze huge volumes of data and then come up with more realistic predictions. That is where the predictive analytics came into picture, because all the tools and the frameworks which were released by these big corporate giants like TensorFlow, PyTorch, scikit-learns, different big data tools with respect to Hadoop, Hive, Spark, and so on. All these tools were used for analyzing a lot of data and giving more predictive analytics applications. Primarily banks, insurance, and other finance companies, they were the ones who are making use of this technology. We are trying to identify who will be the potential customers, what transactions will be fraudulent, and who will be the right set of audience to to capture for the loan processing, right? Likewise, there are a lot of such kind of applications which will help us analyze the systems. The next set of applications which are very common and which are very popular are the fraud and intruder detection. The fraud transactions are nothing but the transactions which are not following a general trend. Now, if you're trying to draw an XY graph, Just a second. So if I try to draw an XY graph and try to plot some data points, okay, so try to draw some XY graph and try to plot some data points. Maybe draw red one only, or dark green. So if I try to draw some data points, what this represents a trend in which the data is going. I can call this as a linear trend. Most of the data can be analyzed like this. This is called as a regression line, where it tells that how the data is associated. How is the linearity of the data? What is the relation between the line from the origin to and the slope? So you have multiple concepts like C, and slope will be called as intercept. You will be doing y is equals to mx plus c, kind of a relation. All those things will be drawn. But there can be some data points which are very different, right? Very far from your actual data. So there could be data points somewhere here or somewhere here. Generally, such kind of data points are called as outliers. So these outliers, what they do is they are not following the correct trend. If you're seeing the actual data points are around the line, around the number line, they are on the number line. But there will be outliers which will be far from the number line. These outliers can also be called as anomalies. Anomalies are the ones which do not follow your regular trend. They do not follow the herd. They are very different. So the anomalies can be frauds. They can be frauds, or they are one of such transactions which are very separate, very different, right? You might not do the transaction, but once in a while you did it. But people will try to identify such kind of things as outliers or anomalies, and then try to flag them. You want to flag them because when you flag them, you want to identify whether it is a fraud or not. And if it is not a fraud, you will try to take some decision on top of it, right? For example, a regular spender who is like a normal person, he will go to grocery shops, he'll go to shopping, once in a while he goes to movies, once in a while he goes to restaurant. If that is a regular life of a person, and if he does the spending, most of the transactions will be on this line, on this red color line. Here and there most of the transactions will be there. But imagine he suddenly buys a 4K television for the great Amazon Indian sale. So he buys a 4K television, say like some 1 lakh. So 1 lakh Indian rupees, he buys a 4K television, which is very different from his regular transactions. He might be buying groceries, going to a shopping mall, watching a movie, going to a restaurant, filling gas in the gas station. So those are all regular transactions, but this one, the 4K television, is pretty much higher than whatever he's regularly doing. Such kind of transactions can be triggered as anomalies, because if I try to plot them in a graph, they will be very different from your actual data. Now that can be a fraud, or it can be a one of the case, right? So generally the banks will try to identify those things and then quickly give an alert. Nowadays you're getting alert for everything. You have dual authentication and other stuff, but imagine in olden days you used to get these alerts on an email, or probably a bank guy will call you saying that, sir, we have seen that there is a transaction of like 1 lakh on your debit card or credit card. uh, uh, we would like to know whether that is you. Or imagine you do a transaction, all your transactions are in India. Imagine these all transactions are in India, and then once in a while you go for other trip. Maybe you go to Singapore on a vacation and then do a transaction on the Singapore. So when you do this, the credit card you are spending outside the country, and the transactions which are not related, and this could be also an anomaly, because most of the transactions are in India, but there is one of the transactions which you went on a vacation and you purchased something in Singapore, and that is different from your regular transactions, right? So such kind of things can also be called as anomalies or outliers. So in fraud and intruder detection, we try to identify these anomalies. There are multiple algorithms again which tries to identify these anomalies which do not follow the regular crowd. You're seeing that the regular crowd of transactions lie on this number line, but these anomalies are very far from these number lines. Such kind of transactions can be identified, and then we can identify whether it is a fraudulent transaction, a person is churning from one company to another company, or he's an intruder who is trying to log into network systems. So likewise, there are plenty of applications which can fall under this category. Next application areas are sentiment analysis. Now, sentiment analysis is where we are saying that we are trying to identify the sentiment of the user. Is it positive? Is it neutral? Or is it negative? So this is a plain vanilla sentiment analysis application where we have information in terms of text, and we are looking at the text, basically a couple of lines, information, comments, and so on. Based on the data, we are trying to identify the sentiment of the user, and using the sentiment, we are able to predict your data, right? Sentiment analysis is kind of a thing where we are trying to predict the sentiment of the users based on the text they are provided. Now, initial days, we used to have plain vanilla sentiments, like we are trying to predict whether it is positive, neutral, or negative. But as the time progressed, we are trying to create applications which can look at the entities of the text and try to predict more entity level sentiment analysis. Now, what are entities? Entities are nothing but the clear demarcations of your data. For example, a comment about a mobile phone can have entity like build quality. It can have a look and feel of the mobile. It can have entity like front-facing camera, back-facing camera, and build quality, battery backup. So likewise, there could be a lot of entities for a specific comment. Imagine you want to buy a mobile phone and you are looking at some comments on Amazon, and you are looking at the reviews, and based on the reviews you would like to buy that mobile phone. If the review goes like this, if the review says the build quality of the mobile is great, the look and feel of the mobile is also awesome, your touch sensitivity is perfect, your battery backup is really good, it runs for full 2 days of a charge, and it takes crisp pictures, but the front facing camera is awful. Okay, so the comment goes with some 4 or 5 positive things. In the last, it goes with a negative thing saying that the front facing camera is awful or it is not good. Maybe the front facing camera could be 1 megapixel, which is according to the current standards is not so good. So if at all somebody who is like an elder who is not worried about taking selfies, and he would like to get a mobile phone which is having good build quality, good battery backup, and other things, then for such a person this will be a good mobile. But somebody who is like a selfie freak, maybe a college goer, or somebody who would like to take a lot of selfies, photographies and all, for him or her, the front facing camera being just 1 megapixel is not at all good, and they might not take the mobile. So from a customer perspective, if you do an analysis, we will try to understand that these entities like battery backup, build quality, look and feel of the mobile, your back facing camera, your front facing camera, all those things are different entities, and based on the entity levels we can also get the sentiment. Now what is the advantage which the customer will get? The customer will get clear information about what is good and what is bad. From a manufacturer also, it will give pinpointed information that what part of your what is wrong in your mobile, right? If you're looking at that, so we are trying to identify like what is wrong in that mobile, and we are saying that okay, because the front facing camera is bad, you're trying to have a bad front facing camera, and because of that you your thing is bad. Got it? So that is how we can create these systems. We can have multiple systems created, and we will be able to identify sentiment analysis of the systems. Both customers and the manufacturers will be profitable. If the manufacturer know that this front facing camera is bad, for the next release, for example, he has released some M10, M20, whatever. Next release, he will release M20s. So you'll say like put an S or X after the release, and that would be a super duper hit. He might change the front facing camera from 1 megapixel to 25 megapixel, and that would become a super hit, right? So it gives both your customer and your manufacturer a great amount of deal. Okay, so just a minute, Lakshmi Garu from Career IT would talk.
Yeah. Hello everyone, this is Lakshmi, Career IT. A small info from our end. This session continuation will be there tomorrow. So the same time 7:30 a.m. IST, and you can use the same link also. So please connect tomorrow as well to get clarity about what is data science and all. So you can use the same link at 7:30 a.m. IST. So if any of your friends there also, please do refer your friends also, guys. You can share our details, whatever we are sharing with you, and the details as well, so that they also can attend, as it is a free webinar for 4 to 5 hours. So you to refer your friends for getting some discount regular sessions. Thank you, guys. Thank you, Sita Garu. Please, you can carry on.
Yeah. Thank you, Lakshmi Garu. Okay, so so that was about the sentiment analysis. So other applications which are very popularly used nowadays, they are the self-driving cars. The self-driving cars, basically they are used in something called as reinforcement learning. So the applications which are used for self-driving cars are reinforcement learning. So in reinforcement learning, what happens is you are not only having not only having the prediction made, but we are also giving the feedback. So multiple feedback systems will be having. So if you're looking at a car, there are a lot of things which are involved. So you might have your proximity sensors, which will be giving the information to the car. You would have the speed sensors, you will have the speed, you'll have braking, different acceleration sensors, you will have different cameras which will feed the data, right? So you'll have a 360-degree camera which can view like the side angles, the front ones, and all those things, which can give multiple things. And apart from that, you have a lot of other these sensory information like speed, proximity, braking, acceleration, your steering angle, and so on. So like this, all these informations, different informations, what they will do is they will try to provide all these informations, and you feed into a machine learning model. So this machine learning model, what it will do is looking at all these different informations, it will again determine like what should be the speed of the vehicle, what should the steering angle. It will also give feedbacks regarding to the braking, acceleration, and so on and so forth. Likewise, there are a lot of things which will be involved in the entire dynamics of the car, and what this will do is it will provide a lot of feedback based systems, not just prediction, it also provides feedback based systems. And that's how the self-driving cars will be used. It's called as a reinforcement learning, where your regular deep learning machine learning models will be involved with a loop. It's a feedback loop. And what this feedback loop will do is it will provide either reward or penalty. So reward or penalty based mechanism where there is looping happening on the model. So if the model is predicting correctly, then it will be rewarded. If the model is not predicting correctly, we will be penalizing the model, so that next time whenever it is predicting, it should predict correctly. So imagine there is a traffic light signal. So I'm pretty much drawing a very bad drawing. Imagine there is a traffic light signal and the car is basically has to stop at the traffic light signal. Imagine there is a red signal here, it has to stop. So if the car did not stop at the red signal, the model will know that the expected is that we need to stop at that particular signal, but it has not stopped. So what it will do is it will send a penalty base, send a penalty to the model. And when the penalty happens, the next time whenever it is crossing the signal or probably approaching the signal, it will look at the red signal, and based on the red signal it will try to stop. So such kind of things can be achieved by the reinforcement learning, and it will give a lot of feedback based mechanisms. So the applications which are used in the space are, you have a lot of gaming applications, you have robotics, of course we have self-driving cars, a popular one is Tesla. So all these things are used in the self-driving car, such kind of applications where we are trying to apply reinforcement learning and use the reinforcement learning for building such kind of systems. The next interesting areas are classification and clustering. So these are the techniques, primarily the ML techniques, which will be used for supervised machine learning and unsupervised machine learning. So classification is a technique in which we are trying to sort it out into one or the other categories. For example, I am getting loan information, loan application information from the bank. A lot of people are applying for loan. So I'm looking at all the details of the banks. I'm looking at what is the salary of the customer, what is the bank balance of the customer, the age of the customer, whether the person is married or not, if he is married, how many kids he have. So all these things are the information which we are gathering, and based on that information we are trying to predict whether the customer should be given a loan or not, right? So if I'm saying that, okay, because his age is greater than 25 and his bank balance is like 2 lakh 20 rupees or 2 lakh something okay, and based on some numbers we are arriving at a conclusion saying that we can give him a loan of 10 lakh rupees, right? So likewise we will classify. So classification is basically trying to predict whether it is a yes or a no, true or a false, A, B and C. Okay, so a person applying for an H-1B visa, he has a lot of information, right? What company he works in, what is the position he's going to, what is the job role, is it a permanent position or not, what is the salary band he's getting, what are the labor laws. So based on all these information we are trying to predict whether his application will be approved or rejected or withheld or some denial, some invalidation or whatever. So if you're seeing, the outputs are belonging to more than one classes. So the outputs can be binary classes like yes or a no, true or a false, approved, rejected, cancer, non-cancerous, like that. or it can be multiple class classification where we are having approved, rejected, denied, withheld, like that. So those are the classification techniques. Classification techniques fall under that supervised machine learning category. And in some cases you might not know what group they belong to, and such kind of techniques are called as clustering techniques. In clustering techniques, we really do not know like what grouping we will be able to create. And so by looking at some basic information, we will try to arrange the data in multiple different segments or buckets, and such kind of algorithms will be called as clustering. In this, we will not have an output which we can associate with. We will just have some bunch of data points, and using those data points, we will arrange in a particular fashion that we would call it as clustering techniques. Another interesting applications are called as recommendation engines. Many times you might have seen these applications, especially on e-commerce based platforms. You're trying to use these recommendation engines, and the technology which is used behind is called as association rule mining. So association rule mining is something which basically finds out the associations between the product, association between product A and product B. So this is A, this is B, and this is C. So the way the identification of associations happen is people who are buying a product A are also buying product B and also buying product C. So we are trying to associate them, that if somebody who is buying the elements of statistical learning is also buying pattern recognition and machine learning and also buying pattern classification. So for that, we try to create this kind of a combinational offers, right? A lot of things can be done. So you can have like discount offers, like discounts, right, with this combination. So you can say discounts, buy one get 20% off on the second, right? You see these things, right? And buy one get other thing free, or buy both of them get it for a discount. Such kind of things, group offers, combinations, all these things can be found out with the association rule mining. When we try to do the association rule mining, we try to find out the association between the products, the similarities in the patterns, and based on that we try to give these suggestions. Because you buy this mobile, and in the bottom you will see that people who bought this mobile also bought the scratch guard and the case and so on, right? Now how did they understood that these people are buying these and things? So when I take the transactions of all these phones, all these scratch cards, and all the cases together, and then I see this, then there will be a quite amount of overlap between all of them. And if the more amount of overlap, you try to give more number of suggestions, and that will give these suggestions, and it will provide a lot of benefit for the customers as well as for the manufacturers. In the real retail shops, they will also change the aisles of the where the placements of the products will work. For example, the bread and butter will be kept together. The bread and butter will be kept together in an aisle. For example, you go to a big shopping mall or some mart, Reliance Mart, D Mart, or Walmart, or whatever. So you go there, and if you go through the aisles of the shopping mart, you would see that these particular products would be kept nearby. And how did they understand that these products would be nearby? Is because their associations is high. And when we see these associations of the product is high, then we can say that people will buy them. Why people will buy them? Because they are highly associated. They are highly associated. People who are buying bread are also trying to buy butter. Maybe they are also buying jam. They're also buying mayonnaise or whatnot, right? So these are associated. So if you have really observed that, you would see that these products will be related or nearby to these other things. Now how they understood that relation is when they performed the association rule mining of the products. they are seeing that these products are highly associated. It is also called as market basket analysis, or this particular analysis, market basket analysis, in which we are trying to analyze the relations between the products, and based on the relations of the product, we are trying to do some predictions. So that's way you do the recommendations. Recommendation goes even more deeper level. So we have something like collaborative filtering, we have some content-based recommendation, you have different other filter recommendation techniques which will be used for recommending movies, YouTube videos, songs, your maybe shirts, choice of the shirts, everything. All those things can be done with these things. Next, another interesting application areas are the car sharing companies, the ride sharing companies, the one second, the ride sharing companies and other things. All those things would be very popularly used, and they will be used for for analyzing the customer data, the transactions, and their analysis. Okay, so for example, if you take Uber, one thing which these companies know is a lot of customer data. When the transactions are happening, who are booking it, what is the time of the day they are booking, which is the place they are booking in, and so on. So because of all these information, we can use it for doing a lot of futuristic prediction, demand analysis, forecasting, and so on. For example, if I want to identify like surge pricing, so if you see like you're booking, you get down out of a train and then you try to book a Uber, suddenly the price of the Uber will be very high. The reason is because many people are booking at the same time at the same place. Then because of the demand analysis, because of the number of cabs around, there will be a surge applied, and unfortunately people will be in a rush, and they will be booking the price for a higher price. Imagine the cost of the trip cost around 150 rupees, they might also give 200 for the same cost of the trip, because they are in a rush, and they do not know whether there will be further cabs available. The analysis which is done behind this is a very simple thing. We do frequency based analysis, which tries to identify by location, by time, by the day, and other kind of factors. We are trying to identify the surge or increase in the demand, and if the increase in the demand is there, we can directly proportionately associate the pricing with the demand. We will increase or bump up the prices with the increase in the demand. Similar is the case when it would like to deploy their drivers. For example, if an Uber driver is there, he really don't know where his next ride will be, and he will be just wandering around the city searching for the next ride, or just staying idle in a place where there is no possibility of the rides. So what these Uber drivers would do is they will contact the center, and their contact center will tell that, please go to so and so place. Maybe there is an IT corridor where by the every day evening from 5 o'clock to 6 o'clock there will be a lot of car bookings happening, and because there are a lot of car booking happening, the number of vehicles are also less, so the customers are also not having the availability of the vehicle. So what happens is, whenever the person asks the company, they know that exactly pinpointed locations, they call it as hotspots, and they know what are the hotspots in that particular area, and they will say that, okay, please go and stand in this so and so location, so and so area, so that their next booking will be within few minutes. So it is advantage from the Uber driver perspective, it is advantage from the company perspective, it is also advantage from the customer perspective. Why is it advantage from the customer perspective? Because they really, whenever they open the app, immediately they see that there is a car in every 5 minutes, right? So the car in 5 minutes, and they will be certainly delighted, and they will continue their service. Such kind of applications are being built. Another interesting analysis is the human emotion analysis. Now, human emotion analysis is basically where we are trying to identify the facial expressions or features, or facial behaviors, the behavioral analytics of the patient, of the persons. And based on the behavioral analytics, we will try to identify and create a lot of applications. And this is very much used in customer serving applications. There's a lot of work happening in this space, from the banking domain, hotel, traveling, transport, hospitality domain. There are a lot of analysis happening where we are trying to use this human emotions, and using these human emotions, we are creating applications. A lot of deep learning applications are used in this space, both from a video perspective and an image perspective. We're trying to identify whether a person is happy, sad, or angry, or a person is a person is astonished or surprised. So a lot of such kind of applications are there, which will create um, these kind of insights. Another important area is genomic data analysis. Now, this is where it will help in the drug discovery. So it's a process in which we are trying to find out new drugs. Now, in the process of drug discovery is very lengthy. It takes a lot of time. We might have been aware with the vaccine of COVID and other drugs which are being tested by different laboratories around the world. So this process is very stringent, and it takes a real good time. The reason is because if somebody invented a drug, imagine a person is getting fever and they have invented a drug called as crocin, and if the crocin has to come into the market, what we have to do is we have to do multiple rounds of testing. We have to do tests on rabbits, rats, small animals, maybe monkeys, chimpanzees, and then to humans. The reason is because we do not want to take chance on the humans. You do not want to test it on the humans. So this entire drug testing life cycle, what we see is right from the small animal testing to the humans. They try to see the behavioral patterns, see like how the animals are behaving with respect to the particular drug. If they are behaving properly, they are behaving positively, then they approve the drug to the next level. This entire process takes a lot of time. So using the drug genomic data analysis, the drug testing and all, what they have identified is they try to identify the genome patterns or the gene patterns of different animals, identifying the similarities of the genes between, say, like rats and rabbits and humans. We try to identify what are similarities and identify those cells and genes. If the drug is having a positive impact on those cells and genes, then what we can say is that drug will also have a positive impact on humans as well, right? So that gives a lot of advantage of providing better creation, better service, and all that stuff. So genomic data analysis is one other interesting area which helps in the drug discovery. Next, another interesting area, this is my favorite also, it's called as Internet of Things. Internet of Things is nothing but, if you watch around now, wherever you're sitting right now, if you watch around, there are a lot of things connected. You might be seeing fan, light, laptop, desk, chair, bed, whatever it can be. In the future, everything is going to connect to internet, and it will be transferring data to that, right? You might also be astonished that maybe in the future the things will talk to each other. Maybe fan talks to the light, light talks to the refrigerator, refrigerator talks to the AC. It can happen, and all these things are possible because these machines are becoming intelligent. They are able to transfer data. Now we are at the stage where these machines are able to transmit data to a centralized cloud, but we are also building applications that basically can transfer data and also analyze the data for creating some meaningful predictions. So in this example, I'm talking about a car manufacturing company. This is a US car manufacturing company which is creating the cars, and they basically have a huge assembly line. And what they do is the car will go from one point to another point, get assembled, and then so on and so forth. They go to multiple multiple assembly lines, right? What it does is it basically creates those different uh, car parts, it will do the moldings, it will do the connections and all that stuff, and in the finally the car will be manufactured. So all these machines have a lot of vital things. For example, you have temperature sensors, you have the lubricant viscosity sensors, you have your lathe machines will be there. Lathe is something like which cuts the car parts, right? So it's the cutting tool which cuts the car parts. So that lathe should be also having it should not have uh, um, any disturbance in sense it should cut fine smooth. There will not be any oscillation, not oscillation, what we call this as um, turbulence. There should not be any turbulence in the lathe. If there is a turbulence in the lathe, what happens is it will the cut will not be smooth, it will be wiggly woggly and so on. So there are a lot of these sensors which are connected to the machines, the temperature sensors, the gyroscope, viscosity sensors, the turbulence sensors, and other sensors which can find out the performance of the machine. And all this sensory information every second will be pushed into a cloud, and on the cloud you will run some algorithms based on looking at the past data. We try to identify which machines are going to go bad in the coming few weeks. And that is a revolutionary change, because in earlier days people used to the supervisors who used to monitor all this entire shop needs to keep track of all this information, and he has to make a meaningful guess whether whether the machine will go bad in the coming few weeks. And because it is human knowledge, sometimes it will be correct and sometimes it will be wrong. It should be purely based on the experience. So many a times the supervisors, they don't want to get fired because the production line gets stopped if one machine goes bad. So what they do is they will procure the parts well in advance, because after the machine goes bad, if they procure the part, it will take some time for the parts to come back to the shop. So it will take some time. So what they do is they will procure the parts well in advance and then keep it in the go down. So it is a loss of money, because the products are in the go down, they're just lying idle, they're not profitable, and because of that they have a lot of problems. So what they do is instead they will procure everything, and that is the loss of business. There is no other chance. So such kind of systems are giving something called as preventive maintenance. They are giving initial clues that this machine will go bad, and what the supervisor will do is they go inspect the machine, try to do further analysis, and then see whether that is real or not, and then they will take a decision. Most probably the decisions will be pretty much correct, because they are based on the past data. If the temperature is greater than so and so threshold, if the viscosity is below some limit, and so on, the machines will go bad. So that is identified by the past data. So such kind of things can be identified, and based on that we will analyze the data. A lot of applications are being created in this space, Internet of Things, and it is combining data science, cloud computing, some part of electronics, sensors and other things, and a lot of work is happening in this space. We already discussed about these. These are called as voice assistants, Google, Siri, Alexa, Google Assistant. All these things work on multiple things, the voice and also the text. So using the voice and the text, we will be able to create systems which will be performing. Another interesting application areas are these what we call as personalized medicine. So personalized medicine is another interesting application area where we are trying to personalize the way medicine is given, the way medical treatment is given, because not everything fits all. For example, somebody very hefty having overweight should require a different treatment, and somebody very skinny and underweight requires a different treatment. For example, both of them get fever and then they go to doctor. the doctor will give one dosage of crocin to the overweight person and one dosage of crocin to the underweight skinny girl. Okay, both of them go back to home, they take the treatment, and then after a few days they come back. The overweight person come back with a complaint that his fever has not subsided, he's still having the fever, so he requests the doctor to give another medicine. Whereas the underweight girl, skinny girl, will come back saying that she has some complications, some side effects because of the medicine. So the same medicine, but given to two different people, has different behavioral patterns. The reason is because the bodily condition, the different elements of the body are different to different people. There are a lot of things: the blood pressure, the temperature, the age of the person, the immunity levels, different chemical compositions of the inner bodily fluids. So there is a lot of things which are different from person to person, right? The weight, height, and other things are also available, but all these things matter, and because of that we can't give one fit all medicine to everybody. There has to be personalized care, and those personalized care can be done with a lot of applications which are created in the healthcare. So the applications are created using something called as EMRs, which are called as electronic medical records. So the hospitals will have all these electronic medical records, which will be which basically take all the data, and based on the data we will try to predict based on the data we are trying to predict what is what is the best suitable medicine for the customers, right? For example, we have an old person, say like age of 80, and he has blood pressure, he has diabetes, and so on. So he will be grouped into a separate category, and another person who is pretty much young, 25 years old, 6 feet tall, and good body build, athletic build, and all that stuff, then he will be given different kind of uh, medications, right? So when we look at the data, when we look at the data points, we can classify or cluster the data points into multiple different buckets. And when a new person comes, we can then classify that person whether he belongs to the cluster A, cluster B, or cluster C. And once we know that, okay, the person is belonging to the cluster B, then we look at the characteristics of the person of the cluster B, what worked for them and what did not work. And based on that, people will take decisions. The doctors will take decisions using these tools which are developed with the help of data science. And they are certainly not removing doctors. They are not like, they're complementing the services which doctors are provided, so they can take more educational guesses rather than just running something on the fluke. All right, understood. So what we are seeing here is we are trying to analyze a lot of these systems. We are trying to understand different applications of data science, see like how they are applied, and then use them for our analysis. So we looked at different applications, and all these applications provide different results. All right, so any questions on whatever we discussed? I think we are almost at the end, so I would like to spend few minutes to answer any questions you have, any general questions or anything. We will be able to take those questions.
No, there are so many different analysis, as you mentioned, the human emotion, the genomic, personalized medicine. So how do we know like which algorithm to apply?
That purely depends upon the data. For example, categorize into structured, unstructured data, and there will be algorithms which will be overlapping. They could be either used for both the type of data. For example, if I use a deep learning algorithm, it could be used for unstructured data as well as structured data. But when coming to the unstructured data, it performs really well and it gives very good results. Whereas the basic algorithms, machine learning algorithms, they might not perform really well on unstructured data. They're very well suited for regular brick and mortar company data, data coming from tables or some flat files, which are having clear input outputs. So in those cases, we would be using that. And when we go into deeper parts of the algorithms, some suit for wide variations of the data, some suit for more complex data points, complex overmapping. Some are used for transformational purpose. Some are used for sparse data. So there are different variations in which, again, when we go into each and every algorithm, we will know like what are those variations and when those algorithms will be applied. But on a broader perspective, that depends upon the data, what type of data you're using. Based on that, we analyze it.
Okay, since most of the data, so basically like end up in the predictive analysis, there is nothing called a perfect state. So is there any way that you use a combination of like algorithms? Because I don't think you can achieve 100% accuracy with the current thing. So suppose like one algorithm is giving me maybe a 60% result. So is there any case that you use a combination of algorithms?
Yeah, the question we are asking is called as ensembling. So ensembling is a process in which you combine multiple good algorithms. So you say like one is giving 70%, the other one is giving 80%, the other one is giving 90%. So you combine all of them and then get more like a state-of-the-art algorithm or combination model, which performs better than individual algorithms taken together. Probably that might give like 92%, and not 100, but probably better than using.
Probably better than. Yep,
Yeah,
got it. Okay.
they are called as ensemble techniques.
Ensemble.
Ensemble. Ensemble or ensemble.
Ensemble. Okay.
Yeah,
Ensemble.
Yeah.
Ensemble.
The different way people call it.
Okay. Okay. Yeah. Different part of the yes. Okay. Got it. Yeah.
Yeah. Any other questions?
Hi. So in the course, right? Would we be taught only on the different kinds of algorithms we have, or would we be in a position that we can, look at an algorithm and we can even customize it or write a new algorithm?
So writing a new algorithm will be dependent on, so utilizing the algorithm, changing the customizing of the algorithm will be taught. But writing a new algorithm required a lot of research. So there are two angles of it. You're coming from a research perspective, academics perspective, or you're coming from a business application perspective. If you really see that from a business application perspective, most of the people are expected to quickly deliver within your agile sprint, and you choose a good algorithm, you try to test multiple algorithms or create an ensemble and then get a better result out of it. Seldom we'll see that somebody who is creating an algorithm. There are research wings within a couple of companies and departments where they will work on those algorithms and then create newer algorithms, but they also use existing algorithms and fine tune and then create newer ones. So our course, they would not be fully focusing on creation of new algorithms, but primarily focusing on applications, like how do we use the existing ones and quickly developed end-to-end applications. That would be the primary focus. There will be a primary focus on how these algorithms are developed. A lot of math will be covered, algorithmic things, and with that knowledge you would be expanding yourself. Maybe if you want to go build a new algorithm, right? So it will help to build that also. Did that answer? Because if you're practically many they don't ask you to write a new algorithm, because that is a research. It would take a lot of time, and because if there are state-of-art algorithms already available, why the hell will I go start writing an algorithm? It's not my PhD project. So that is the reality.
And what do you think is the fundamental quality of a good data scientist? So
I would say that he or she should be able to analyze data. He should be able to understand the patterns of the data. There's a lot of pre-processing, cleaning, garbage cleaning kind of a thing is required, because the models are now becoming just like an on-the-shelf plug and play things. In the future, they will become even more. So the actual quality lies in identifying the right set of inputs, right variations of the inputs, and then creation of better pre-processing things and so on. We spend a lot of time on that also, because once we prepare the data, plugging into a model and getting a result is just quickly, it doesn't take much of a time. But the way we analyze data, what components to be involved, how much data to be involved, what cleaning to be done, is something very important. And he or she should also have a connectivity with the external applications. He should be knowing how to create APIs, how to deploy models, how to connect to a cloud, how to productionize this entire application. See, all those things are also important. And many places, they don't talk about it. They just say like, okay, apply the model, get 70%, 80% accuracy, then you're done. Machine learning is done. But that is not done. That's not even halfway done. It's a lot of other things are involved in that.
so you need a little development background or some scripting, or like how do you?
For that, that's a bigger question. I have to spend another hour for that.
Oh, is it okay?
Tomorrow's topic, I'll be talking on end-to-end machine learning, where I'll be covering about, if I'm coming from a data background, a data warehousing, some other background, where would I fit? If I am coming from a development background, I did some Java programming, or I am a C# developer, so where would I fit? If I am a tester, like where would I fit? And if I am a newbie, like I just completed my BTech or MTech, or I just joined a company and I want to learn this and I want to get my growth, where would I fit? So these are all
Okay.
bigger questions. I think tomorrow we will spend quality time in discussing
Okay.
all those things. I would recommend, please do attend tomorrow also.
Definitely. And thanks, Sitaram. Yeah, that's pretty much from me, and thank you. That is very it's a very good session, and I've gone through many videos on YouTube, but this is like so much precise to the point, and it really was helpful. Thank you.
Appreciate that. Any other questions? We can spend few more minutes. So please do attend tomorrow's session. It is very important. According to me, this is all talking about gray area of applications and all that stuff. But tomorrow's session, we'll be talking about different connecting parts, how the data will be analyzed. I'll be talking on different not applications, but the applicability in the real world. So whether you join or not, that is immaterial, but I would recommend to spend some time tomorrow. Same time, I think 7:30 to 10 o'clock is the time. So that would be the time. We will do a 2-hour session, 2.5 hour, with a small break in between. But I would recommend to attend that one. All right. Well, thank you very much, guys. Thank you for patiently listening to me. And we will catch you tomorrow, or else no problem. All right. Thank you.
Thanks, Sitaram.
Thank you, Sitaram.
Thank you very much.
Yeah, nice one. Thank you.
Thank you.